for those of you that don't know, I guess the two of you, so JUnit is this framework for, that was invented by Eric Gama and actually another guy back in the Stone Ages, I guess, that long ago. And it's basically a framework that facilitates, makes it easy for us to set up a context that's usually required for unit testing. There's a whole lot more that we can talk about on JUnit. I don't want to take the spotlight away from Taylor, but it's definitely one of the frameworks that you want to be familiar with, whether for Android or any other related Java project. So let me show you the very simple application that actually this is something that my brother built, Marco, because he teaches Android from time to time. So he actually wrote this little app. It's a very simple app that basically, you can see it just has one activity. I'm assuming you guys understand enough about the Android SDK to know what activities are. It has a very simple, I guess I could show you the layout very quickly. It looks like this. Well, once it opens up. It's a little weight converter, right? So it's got, kilos input box and pounds input box, and you type it into one, and it gets converted into the other. Okay, nothing really fancy, but I guess it's helpful for those of you that just got here from France and don't quite understand the imperial system. So it took me a while, for sure, believe me. And it's not necessarily the most, the best way to implement an app. You can see it's got, these key listeners. They basically listen on inputs into one box and effectively do some manipulation to the data or parse the data out of the input box or the edit text and effectively, populate the other entry box. And, there's a redundancy in how this is implemented. So there's, he implements this on key listener twice. It could have been done better. It's not even important. Let me just show you what this looks like when it runs, and then I'll show you what this looks like when it's actually being tested. So running it as an Android application, so in my little emulator, it looks like this. Okay, so you say, for example, 1 kilo, it's 2 pounds. If you keep typing, it keeps on converting. If you go over here, and you keep on typing, you'll see that it kind of converts in real time. Okay, nothing fancy. There's no buttons, nothing else. So how would you go about testing this? Let me just quickly show you that. So in Android SDK, the idea is, if you were to use their best practices, is you would actually go and create a new project, but you wouldn't create a standard Android project. You would create an Android test project, and by doing so, you would link it to the project that's actually being tested. So a test project is where you define the tests themselves, but those tests are going to run against the actual app that you wrote. So, and the idea, behind separating these two things is so that you can easily package your app, I guess, separately from all your test-related code. Okay, which is somewhat different than most of us. We're used to kind of having our test code be, very close to our source, not in a separate project. Anyways, this has already been created, so let me just show you what this looks like. Once I created this test, basically, you'll notice I have a file here called test demo tests. It extends something called activity instrumentation test case 2, and I guess they got it wrong the first time around, so now they have a 2. And there's a little bit of generics involved here to make it easier for the system to set up the test for you, to build a context, I guess, of the activity that's being tested. In this particular case, this test, just holds on to some variables. I guess for the input boxes, I guess keep on calling them input boxes, edit texts, and then the actual activity that's being tested. There's nothing really fancy in the setup. In the setup, we effectively just get the activity. Now, we don't know how and where the activity gets created. The system figures it out based on the fact that you've basically said, hey, I want a test demo activity to be created. We don't have to worry about the context or how that launches. Effectively, that's what the activity instrumentation test case provides to us. Here we go, and this is interesting where now that we have the activity, we can find the views by IDs. I'm sure you guys have done this a million times if you've done any kind of Android development. And we need these so that we can kind of introspect them later on. So here's a little, simple test. And by the way, These tests, based on the JUnit 4, annotation-driven markers, I guess, are annotated with small tests. It starts with test, views created, and then just like you guys maybe used to, we have this, assert not null. The idea is that, we're just really asserting that the system actually did what it was supposed to do. And I guess that that these two views actually exist within this activity. Nothing too fancy about it. This is, I guess, a little more interesting. This is where it becomes a little more Android specific. So here we're basically saying assert that this edit pounds edit text is in fact on part of the view, that it is on the screen. It is actually being rendered. Okay, and obviously the same for the kilos. It's not necessarily again the smartest test in the world, but again, just want to show you some of the extensions, I guess, that Android framework is bringing to the JUnit framework. And then here's where it's getting, I guess, a little more interesting. You're saying, hey, let's check for whether this is, whether it's being initialized to empty. And then here's where it gets really interesting. Is here we're basically, clearing the boxes. We are going and simulating a tap. So we're effectively simulating something that a user can do, clicking on the text box in order to give it focus so the user can actually type in this case, send a number. So here we're doing something called send keys. We're simulating user typing, whether it's on the keyboard or on the soft keys. And then here we're actually, now that we have access to the pounds, to the other box, we actually can grab the string from the pounds, we can parse it out, and then we can do an assertion to check whether the conversion is somewhere within the normal range. Okay? Again, it's nothing too fancy. Of course, this can be done a million times better. The idea is just to introduce you to how this is typically done in the kind of best practices way. So let me show you what this looks like when you run it. So if you click on this and you say run as, you're now not running as an Android application, but rather as an Android JUnit test. So you click on that, which basically now, which is where it gets interesting, is going to run in the emulator. Okay, so notice what happens right now. Just watch. See how it gets actually, the application gets started. You see how 1 was being sent as an input into the field, and then the application does its job and converts the 1 into whatever, 2.2 something kilos, and then basically the system checks for that. In the Eclipse side, we know how many errors and failures and whatnot we had. Okay, I don't want to, this is the end of the discussion as far as, how this works. I just wanted to give you a taste for what effectively Robolectric is replacing.
Thank you, Sasha. So I'm here to talk about Robolectric. Thanks for the intro. I guess you guys know what this is. We have a website. You can be found, it's on GitHub, so it can be found at pivotal.github.com/Robolectric. If you Google it, you should be able to find it. It's a unique name. I'm Tyler Schultz. My title is Agile Engineer. I work at Pivotal Labs. We're located on 3rd and Market. I write software, particularly Android software. I'm going to start talking about testing and approaches and alternatives to Android. So that was a great introduction that Sasha gave us because I don't have any great demos like that. So that's kind of the starting point from where Robolectric came from. We're going to talk about how Robolectric works and how to extend Robolectric, and then I'm going to spend some time at the end for doing whatever you want. We can help you get up and running, we can write tests, we can do demonstrations, whatever. Just a few more words about Pivotal. If you're into writing JavaScript and you write JavaScript code, you may have heard of Jasmine. It's a JavaScript testing framework. We have one of the maintainers here, Christian, is a maintainer. I have lots of people planted in the crowd from Pivotal here. So Jasmine is a BDD style, test style framework. If you're familiar with like RSpec in Rails, it's this style of testing. We have Cedar is something else that Pivotal's come up with. Adam, the lead of mobile at Pivotal, has recently released Cedar, and this is one of a kind thing there as well. I don't think there's any other test framework out for iOS or Objective-C going on right now aside from this. And it again is BDD style, RSpec style test framework. And you can find these guys on Twitter at Jasmine BDD or Cedar BDD. And the other great claim to fame that Pivotal Labs has is Pivotal Tracker. And if you're running a software project and you're not using Tracker, you should. Check it out. At Pivotal, at a meeting recently, a company meeting, we had a section of the meeting dedicated to just shouting out answers to questions that Edward wrote up on the screen. And I thought it was kind of an interesting exercise. And so one of them, like why do we, at Pivotal Labs, we do a lot of pair programming. We do a lot of, we do agile methodology there. We do pair programming. We do test driving. We do extreme programming, continuous integration, all these great buzzwords that are in the software industry now. We do it, we live it, and we don't just give a lip service. We like to think we do it, and we do it well. But one of the things we did at our meeting was we talked about what we value, like why do we like unit testing? So I don't know how many people here are into unit testing. I guess Sasha already asked my question, but why do we unit test? Does anybody have any reasons why we unit test? Keep the code clean, save time, stop regressions. It helps you design the software, makes you think about what you want to get done versus how you want to do it. One of my favorite ones is it's an executable specification. So instead of it being a document that tells you how your software should act, this is a specification that you can execute against your code. And if it's wrong, bling, you get red lights, and you know what went wrong right away. So we love to unit test, that we make it. This is the only way we write code. And so maybe I can win some of you guys over who don't do it. How many people have tried to write a unit test and seen this? There you go. A couple people out here. So what this is Google, the jar that Google provides that your IDE is using to compile against is just a shell of a jar. All the classes have had their implementation stripped, and all of the methods inside of the Android jar throw new runtime exception stub. So this will spew out in your console if you try to run a unit test in your IDE or at your command line. If you're not running in an emulator in an environment where the jar has an actual implementation, you're going to get this, and it's troublesome. It makes testing really hard, and I guess I can understand why they would do it, but I don't like it. Some of the additional challenges that you'll have when you try to write tests for Android is that many of the classes and methods are final. So you can't do things like extend a class so that you can override the behavior of the class for testing, or you don't really want it to make a remote call, so I'll just override this method in the case of this test. You can't do that. A lot of places the SDK shuts you out. There's no interfaces in Android whatsoever. I believe in their performance section of their website, they talk about interfaces being non-performant. So there's probably a lot of reasons why that I don't even understand. But when you're publishing a public SDK, they try to keep it locked down so that people don't tweak the SDK too much. So the other challenge is non-public constructors. So you can't even construct the objects that they have provided. And they make use of static methods. If you're into unit testing, you understand all these things kind of make writing tests for your code hard. Not insurmountable, but all of them together make for an awful experience. So this being the case, here are some of the approaches that we have taken when we're writing tests. So the first app I wrote at Pivotal, we were kind of shocked and taken back when we got into writing Android to the lack of testing support that was there. And we tried to write a bunch of tests like Sasha showed us, but we ran into a lot of the problems that we just talked about. And so we just gave up. We didn't write tests, and it was awful. There was another approach we thought, okay, well, we'll get as much code out of the Android code base, and we'll make a separate library, and we'll unit test that, and it won't have any reference to Android, and it'll just use plain old Java objects, and you can unit test the life out of this stuff, but all of your Android code is still going to be untested. And so your Android project would refer to this tested code. So you're getting some coverage. It's maybe a little better, but it still leaves a lot to be desired. And then there's other approaches you could take, such as mocking frameworks, as EasyMock and Mockito. Are people familiar with that? I believe if you do a Google search and you hunt around, you'll find a Google code page that some of the engineers have posted. In their 20% time, they're demonstrating how to write unit tests for your Android code using mocks. And they say, stick around for more, more's coming, but I think it's been a year and nothing's come. So, enter Robolectric. Christian, I've already pointed him out once. He's responsible for Jasmine, one of the people responsible for Jasmine, but he wrote the core of Robolectric when he was working on a project at our sister company, Extreme Labs in Toronto, and we just wanted to give a shout out and a thanks to them. And I didn't know where else to put this next statement, so I just shoved it in this slide. And it's Robolectric is available under the MIT license. So if you want it, you can have it. You can tear it apart. You can steal it. Do whatever you want with it. Pivotal, we forked their repo and we renamed it Robolectric, and it used to be called Droid Sugar. I don't know if anybody even were familiar with it. It's been out there for a little while, but I don't think anybody even knew it existed. So we're here trying to publicize it a bit. So we've renamed it, we expanded its functionality, and we've used it on several projects now, and we love it. We think it's great. We want to share it with the world, and we want to get everybody else's energy behind it because we think this can go places. So I'm talking about this Robolectric thing. Why should I use it? Why is it so great, Tyler? Tell us. So I'm going to go through some of the comparison and contrasts with some of the testing approaches that I listed before. So starting here with the Android instrumentation tests that Sasha demonstrated for us. Thank you again. That was nice. That was a good intro. You saw that when he clicked run on he's got a nice, hot, fast machine. He clicked run on that thing, and you could see that there are several steps that are required to be able to run these tests. First, you're going to have to compile your production code. You're going to have to compile your tests, and then you're going to need to dex them, which is converting their bytecode, the Java bytecode, into Dalvik VM compatible bytecode. It's got to be packaged into an application. It's got to be installed on the emulator, and all this with a large app. Like Sasha's app is fairly small, but if you're dealing with hundreds of files, this is going to take forever. So just getting through that first step, and then once the tests arrive there, they execute fairly slowly. We could see the green bar progress across there for 4 tests, and you could see the screen flashing. There's a lot of overhead there, and there's other problems with it too. Once your application becomes a little bit slower, you run into flakiness, kind of a bad experience. So Robolectric, we run the tests in the JVM. We don't bother dexing, we don't bother packaging, we don't bother installing the emulator. We're going to be running them locally on the workstation. They're not going to be running in the emulator. So what this buys you is you can iterate quickly. You can write your failing test, you can see it fail, you can see it's failing for the right reason, you can write your implementation and run your tests again, and you can iterate quickly. You can do this fast. That's key if you're going to be writing tests. If you can't do this fast, it's just going to demoralize you and make you quickly abandon it. So in our project that we were working on latest, we have over 1,000 tests, and they run in under 30 seconds. Now we're going to compare Robolectric against the Pojo lib approach. So this is going to lead you to write code with a lot of interfaces and a lot of multiple implementations. You're going to get a lot of code bloat. You're going to write a lot of code that you're only writing because you're trying to use this approach. It's better, but it still sucks. How about that? So with the Pojo approach, your tests are going to run fast because they're going to be just plain Java tests, and when you're just dealing with plain old Java objects, the tests seem to run really fast, which is really nice, except that a large portion of your code will not be tested. So all the code that calls into the lib will not be tested. All of your Android code. So Robolectric has this approach beat as well because now you can get all of your code under test. So I'm probably going to offend people here who like mocking frameworks. I dislike mocking frameworks. They can lead to tests that are reverse implementation of the code. So your tests will end up asserting that your code, it's almost like a mirror copy of your code ends up in your test, and that's not helpful. It just cements your code into the way that your expectations are set. It can lead to tests that are hard to read. I know when I open up a test that's been written with mock frameworks, it takes me a lot longer to understand what is happening and what's being tested. And in the end, it leads to tests that don't help with refactoring. If I want to extract some behavior out of a class, or if I want to fold some code down, this very often will break all of my mock tests, and it doesn't really help me with refactoring. Okay, so why do we want to use Robolectric? We can iterate quickly. We can allow, Robolectric will allow you to write black box style tests. So you can just test the way, when I click this button, what happened behaviorally with the code, with the state of the world after this behavior has been taken place. And you can test all of your code versus just code that you see. Back to Sasha's examples. These are tests where it's almost like, is anybody familiar with Selenium testing? So activity instrumentation tests are much like Selenium testing. It would be horrible to write a web app and test driving it through only Selenium. So if you weren't able to unit test your code, you would be suffering through long runs of slow tests, and
they're brittle too.
They're brittle and flaky, and all the problems that we've just discussed. I think there's a place for possibly these instrumentation tests. We just haven't found it yet. Like, I think now that we've got unit testing sorted out, I feel like it's probably worth that we take another look at activity instrumentation tests, but for the time being, we've pretty much given up on them. So I keep saying Robolectric does all these things. How does it work? I told you guys that Google stripped all the classes, and they all just throw runtime exceptions, which is awful. So there's two major things that we'll go over here about what Robolectric is doing to make this happen. So there's shadow objects, and there's view and resource loading. So these are two major feature sets of Robolectric that we'll kind of go over here that make this all possible. So shadow objects. What are shadow objects? So what's happening when you run a test inside of with Robolectric is that it's going to intercept the loading of the Android classes. And this only happens under test, by the way. It's not going to happen when you're running your production code. So all this is outside of your production tree. So when an Android class is encountered, there's a separate class loader that's in the works that Robolectric has, and it will rewrite the method bodies of all of the Android classes. And it uses a library called JavaSys to do this. It will create a shadow object that will give behavior to these Android objects that are nothing but shells. And the modified Android objects proxy method calls through, so the method bodies of the Android objects have been rewritten to call through to these shadow objects. I'll go over this more so this become more clear, but basically we've implemented the SDK, at least partially, and in a very rudimentary way. And it's not as bad as it sounds, I promise. So shadows back the Android classes. For example, shadow image view backs the image view class. And so this shadow image view doesn't actually draw anything on the screen. It's just an object that's going to hold the state of the world as you manipulate it through your application code. The method calls to the Android object or proxy to the object shadow. I think I've already said this. So like if you call getText on a text view, the method body of the text view will have been rewritten such that it will call through to the shadow and say, shadow, do you have a method called getText? If you do, I'll return the value that you return me. And so this shadow object is delegating to this fake implementation of the Android object. So it's totally headless. There's nothing going on there. So they're very rudimentary implementations. And also, so now once you've changed the state of your image view, this object will hold on to that state, and so now you can make assertions against it in your tests. The other major piece to what Robolectric is doing view and resource loading. So all of the files that are under your resource directory of your project, such as your layout files, your IDs, your strings files, all of these types of files, they're getting parsed by Robolectric, and they will build a tree made of these Android view objects, and of course they're shadows. So every time, if you had a layout that was a linear layout and it had a button inside of it and a text view, you would get a tree of objects just like that, and you can actually reference them from your production code, and they can stand in, and you can do your tests outside of the emulator this way. So some of the view XML attributes are applied to the view object, such as the, so we only implement just a few of the XML attributes that get applied to the objects, and they seem to be, we only built them on an as-needed basis, and these are the ones that we've come up with so far. So ID, visibility, enabled, text, checked, and source for image views. And this has taken us a long way. We're able to test a lot of our code. These are what we feel is important when we're writing our app. So if you, we'll come to an example where this will make more sense. Other things that are going on, like strings and string arrays and color resources. If your text view is assigning a string value, a string ID inside of the XML, so if you have like @strings/hello world, when you ask that text view in test, what is your content? It will be the content of the strings file at that entry, hello world. So this all sounds great, right? So Robolectric is the library that has all of the magic in it, but Robolectric Sample is a project that I wrote. I've been on paternity leave, so I had some time to write a sample app, and it's up on GitHub, and you're free to download it. Right now, this is probably the best way to get set up, is to download this app and put your code into there and rename it and just use it as your template for your project. We tried to put together instructions for getting set up, and it was awful. So it is complex, and we have it on a roadmap to simplify getting set up and running. But for now, we're kind of going with use the sample app. Here's how you can get started with Robolectric. You can clone you can clone the repo. You can go in there. You do. So we use Git, and we use. You'll need to have Git. You'll need to have Ant, which you probably do have if you're writing Android apps. And you'll need to have the SDK installed, of course, and Java. So with these commands, you should be able to clone the repo, get into the directory, initialize your submodules. So if you're familiar with Git, you also need to understand what Git submodules are. Again, this is complex, but we hope to make this simpler. Just make it like a jar you can drop in. We'll have time to dedicate to making some of these improvements I'm talking about, but if you are familiar with Git and these things, you should be able to run these commands, and you can find these commands on the Robolectric sample page, and you should be able to run the tests. So here's we're running ant clean test. So this means it's going to compile your project, it's going to compile your tests, it's going to execute your tests against, it's just going to execute your tests, and if your tests fail, your ant task will fail, and this is great for Hudson. So we do. In the sample project, we've provided a build.xml file that has all this set up, because the setup of the project is a little bit complex. This test task is, again, useful for continuous integration. We use it on our Hudson server as well. And here's the other rub. So we are IntelliJ fans. We prefer IntelliJ over Eclipse. So we don't have support for Eclipse right now, and we're sorry. We'd like to get it going soon, so we plan on spending a lot of time working with this. But the good news is that you can download the IntelliJ EAP and not need a license. You should be able to still at least open up the project with Eclipse. You may not be able to build necessarily, but you can always use the ant command line to do that as a stand-in the meantime. That's less than optimal, of course, but we would like to get this going soon. So if anybody is motivated and understands Eclipse well, we'd love your help. So if you're familiar with IntelliJ, IntelliJ has this notion of modules, and they're kind of like little mini library project artifacts. And the Robolectric sample is the main Android module. So IntelliJ knows this as an Android project, and it knows that if you edit the XML files, it needs to regenerate these Java files. And so forth. So that file, that module is there. We also have Robolectric, which is a Git submodule as well as a IntelliJ module. So if you're not familiar with IntelliJ, you can cover your ears. But we have another section in there for AIDL, which is where if you're using services and you're communicating remotely with them, you have to write AIDL files, and they get generated into, it's basically like RPC framework. You put your AIDL files in there, and then the code module is where all of your application code and tests go. So the reason, why did we break our application code and test code out of Robolectric Sample, the main Android module? Well, the reason is when you run tests inside of the Robolectric Sample main Android module, it would go through all the steps of regenerating all the code. It would do all of the dexing and packaging and so forth, which is slow. So by moving the code out of that module, and the Robolectric Sample project refers to the code module, so if you put your code in here, now we can compile and run very quickly. Another side note is that when Robolectric Sample builds, it puts its generated files into the code module. So your code module can refer to all the generated classes. So if you're going to write some tests with Robolectric, you need to annotate your test. So we're using JUnit 4 as well, and it requires annotations. And the run with is a JUnit annotation, which allows you to get your hooks into the loading of the classes during. This is where Robolectric inserts itself and gets its class loader intercepting the loading of classes. And once you've got your JUnit test written, you should be able, and you have Robolectric installed, you should be able to write a test that looks something like this. So let's take a minute and look at what's going on here. The first line, we're instantiating our activity, and if you were not running with Robolectric, you would have failed right there. You would have got your throw runtime exception because you would have called the constructor, would have called super, which would have been the activity class, and it would have thrown a runtime exception stub. So because we're running with Robolectric, we've rewritten that method body, and we're good to go. Then you would call some of the lifecycle functions as necessary. So onCreate is always going to be called whenever your activity is running. So we call onCreate. We don't have any saved instance state. We're passing null. And inside of onCreate is typically where you do your set content view. I forget the name of the method, but basically this is where you specify your layout. So our layout has been assigned. We have an activity. onCreate has been executed. So everything that would have happened inside of onCreate has been set up. So now we can do things like find view by ID, and if our layout had a logo and a button on it, we could do find view by ID and get reference to these objects. And these objects would have shadows behind them automatically. Now we can assert on these view objects. So we can say logo, what's your visibility? So we've implemented the get visibility. And we can assert that it's gone. Like suppose in our layout we had said this image is gone. So we can assert that that's the state of the world when when onCreate has been run. Then we can click on the button. Perform click is an Android method. It clicks, and this would cause the click listeners that you registered on this button to get fired, and that would cause your application code to run. And now we can say, oh, now the visibility of this logo is visible, and we can assert that. And the state of that image view that had been manipulated in our production code can be asserted on here in our test. So there are problems, though, with this because Android doesn't always necessarily expose a way to get at the state of an object. So image view is the one that always comes to mind for me. You can assign, there's numerous ways to get an image into an image view. There's no way to get that state back out. The only way to get state back out of an image view is to get the drawable. We didn't want to go through the trouble of making drawables comparable and so forth. So what we can do is expose the shadow. So suppose in our layout we had an image view and we applied a logo drawable in our source tag there. What we've done here inside the red box in our test, we've said, Robolectric, I'd like to get reference to the shadow delegate object that's backing this image view, and I'd like to be able to find out what is the resource ID on this image view. And then we can assert that it equals the logo drawable that we assigned up in the layout. we implemented a lot of shadows. And here is the method where they're all registered. So you can see we've got a lot of them here, but we haven't got the whole SDK yet. We've got a lot of them. This should get you a long way, but of course, being in the public, someone will find a way to, or want to write a test that we haven't implemented a shadow for. So if you wanted to implement a shadow, here's some of the things that you'll have to understand about shadows. There's the real object annotations. So what this is suppose someone were to new an activity. Robolectric would have intercepted that class loading they were to new an activity under test. Robolectric would have intercepted the class loading of activity and rewritten all of its method bodies. So it would have rewritten its constructor. It would have rewritten all of its method bodies, regular method bodies as well. So it's using reflection. So when a new activity is instantiated, Robolectric is going to use reflection to look for a shadow that it will instantiate to back this activity. And it will call off to a no-args constructor. And this is important to understand because of the next annotation we'll come to. But sometimes when you're implementing your shadow, it's helpful to have reference to the real Android object so you can return it from method calls and so forth. Like a lot of times a click listener will want the actual Android object to pass through to the click listener, for instance. So Robolectric will inject the Android view object onto the shadow, and it will inject it onto the field that's annotated with real object. So if you have shadow view here, you can see that if you've got real object annotation on the view, you can get reference to the real object in your shadow this way. So if no shadow class is registered for an Android class, the Android object superconstructor will seek out a shadow class up to the constructor superchain until one is found. So what this means is that suppose you're way down at the bottom of the hierarchy at checkbox, and you instantiate a checkbox in your application, and Robolectric says, well, wow, I've got no shadow registered for a checkbox. Oh, well, I'll just call the superconstructor, and that superconstructor will again say, oh, wow, no shadow is instantiated yet, so it will go up through the view hierarchy until it finds a shadow backing class to represent it. If no one has ever found, all of the methods on the classes will proxy to nothing and return nothing. They will not throw exceptions, but they will return nothing. Sometimes, though, when you call a constructor, you're passing arguments to a constructor. So take, for instance, an intent. When you construct an intent, often you're passing in a couple of arguments to the constructor, and you want to be able to get those arguments into the shadow. So this is implemented by Robolectric will seek out a method named constructor, and it will have to have the same arguments as the real constructor. So you can see here on intent, it takes a string and a URI, and if Robolectric detects that there's a method named __constructor__ that receives an action, a string and a URI, it will invoke that method with the arguments that were passed to the constructor in the first place, to the arguments passed to the real Android objects constructor. So this is helpful as well for getting state into your shadow. And that's an artifact of because we're instantiating the shadows with reflection. The @implements annotation on a shadow is saying this class is acting as a stand-in, as a shadow for the view class. This is how the Android view class and the shadow view class are bound together. This is how they are registered. The @implementation annotation, take for instance a text view class implements getText. And we want our shadow to respond to getText and not just return null. So we can write the getText method on our shadow, and we can return whatever value we want in our shadow. And this @implementation annotation tells Robolectric that, hey, I intend for this method to be an implementation of the real Android object. We're not part of the other objects hierarchy, so we can't use the override annotation. And there's a lint test that makes sure that you believe you are implementing a real method on the object, and this will verify that if your method is not found on the real object, you will get a test failure. So this is a little bit of just a catch. If you wanted to see all the shadows that Robolectric provides now, you can go to this method and see them all. So we do have some of the things on our roadmap, Eclipse support. We want to simplify the setup because we know it's a bear. And we're always updating the shadows and adding behavior to them as needed. One of the things that we don't support that I think is important is that we don't handle all the different types of resource overrides that you can do for high definition, high DPI phones or, landscape mode folders and so forth. So these are some of the things that we hope to work on soon. And so now is when everybody's really excited and they want to do this. So I can help you get your workstation set up if you're running a Mac, of course. And if you're interested, you can get the latest IntelliJ EAP off of my machine right now. If you go to tschultz.local, there's a web page there. You can download the EAP off my box. I don't know how long it'll take to get over the Wi-Fi, but it's got to be faster than the internet. And there's a lot of people here who have experience with Robolectric if you'd like to get started and give it a shot. So thanks for coming out, and thanks for listening to our presentation.